Hello folks, this is Doug with Imagination Mechanical and Fabrication coming to you once again. A little bit of an update, but also I'm going to be working on a compressor. You can see it right here, and I'm going to video the work going on the compressor. And so, but I'll also show you some of the stuff that I think some of it I've showed on my last video, but I'm going to show you some other stuff I've been working on, but this here is sort of, kind of a critical thing. So I kind of wanted to just show the process, and maybe you might be interested. So without further ado, I'm going to get my mug off of here and show you what I've been doing. All right, now. Trying to swap this thing around, it wants to be aggravating with this cover I got on this phone. I worked on this. I still got to finish it, but I got some paint stripper and put on it. It was painted black all the way around on the top and the ends, and I got the majority of it off. And now I just got to get a razor blade scraper and just get the rest of the small stuff, and maybe a little more of the stripper, and put on the metal there to get that last little bit off. I tried to scrape that off, but it's got like little small dents in it and stuff, and so it just went over it. But I'll put a little bit more of that cleaner on there, or stripper on there, and then take a Scotch-Brite or something and get that off. But been doing that, and of course I rearranged stuff again. I got all this stuff over here, these bed stuff that I want to get out of here, and I got this set up to work on. I've got to get a potential relay for it. I thought I had one. This is the one I had, a little potential relay, and I know I've got the one that came off of this thing somewhere. I brought it up here and I put it somewhere, and I just ain't had time to look for it. But and I did start working on getting that junk off of that one back there. I've weeded it down some, and as you can see, I added a place for my nut drivers there. I got to get the rest of the ones for the metrics there. I don't have them. I don't know where they at. And my compressor, as you can see, is sitting here, and it's still holding pressure. I cranked it up last night and to air up one of my tires, and I just fill this tank up and take it out there and fill up my tires. But it seems to be holding pretty good with my repair to the check valve. And I said I was going to build a stand for my drill press. Well, there it is. Just something I throw together. Nothing, just using scrap pieces of wood, and put it together. And it seems to be, it's just where I want it at height wise. And then I got my cabinet over here with all my drill bits and stuff in it. And I think I may put this grinder right here. There's a plug right back there, and I just sharpened this old chisel here, sharpened it up a little bit, just cleaned it. It was all rusted up, and it's bent. It's bent down. You can kind of see it a little bit. It's bent. I don't know where I got it from, but I'm going to use it if I have to get this. This is what I'm going to be working on. This is a Copeland semi-hermetic compressor. It is, I think it's a K body. Yeah, if you look here at the serial numbers, it's a K, and this is a rebuilt one because it's got this blue tag on it. It would be a red tag if it was or a black tag, red or black, if it come brand new. But when they rebuild them, they put the blue tag on there. And it's a company that rebuilds them for Copeland, that they own. It's their company, but it's not Copeland directly. It's like a rebuilder that they bought up or whatever that does all the rebuilding. And The problem that it has is it's leaking. And I don't know when they rebuilt it if they put new seals around I'm beginning to think they didn't. You know, they probably just fixed whatever the issue with it was, you know, maybe drop valves, or maybe a broke crank, because it's like a little engine. I mean, it's got a piston in it, and it's got a crankshaft, and or something like a crankshaft with a connecting rod on it, and it comes through, and there's a motor built in here in this body, and I'm hoping that the motor stops like right here, because these are the terminals right here that are going down into the motor. They're called bulkhead fittings or whatever, bulkhead terminals, because they're coming up through from a high, you know, a pressurized system to a non-pressurized system. And so I'm hoping the motor stops like right here, and I don't have to pull the stator out. You know, the rotor, I think they have like a shaft coupling that goes from the rotor to the shaft that is connected to the piston, to the connecting rod. And so, and you have to have like a special tool to pull those stators out. You know, like a gear puller kind of thing, but it's for pulling out those stators. And then that means you got to pull the rotor out and all too, and which means you got to go into the, and let you know, again, I'm not sure exactly how they do those rotors, because I've never rebuilt one of these. The only thing I've ever replaced on them was I put reed valves in them. They got reed valves that are spring steel, flat spring steel, and they, on the suction side, they open up like that right there down, and the gas comes back in and gets compressed, and then it pushes up against a valve on this side, a discharge valve. It pushes up on it like that. One goes up, the other one goes down, and it pushes up on it, and the gas, the high pressure discharge gas comes out of here and goes to a condenser. And so what I'm going to be doing is I'm going to be pulling this bell end off and looking in there to see what I got to do to you know, to put new seals in there. And so that's kind of where I'm at. And so I'm going to put this on my ring stand over here. Hopefully I'll get it to where y'all can see it, and then we're going to go from there. All right, folks, so here we go. I'm gonna pull this end off. Got my old DeWalt impactor. I'm gonna see what this thing can do. Another thing I got to do whenever I do this is I got to, you know, get a gasket kit. I want to get gaskets for these service valves on here. And I got to get one for this bell end. And I got a set of manuals for these things. I got to find them, because they'll have all the torque specifications and stuff in there, because these have to be torqued back down like an engine, because they look like a little small single cylinder engine. But they make these in all different styles and sizes. I mean, this is a K body, but they got D bodies and C bodies, you know, two-stage compounds, which a compound is a compressor that has two cylinders on it, and it has an interstage on it for, you know, like cooling it, because these things get hot. And the way that these little small ones are cooled is the return gas. Let me turn this around here where you can see. That light's a little bright, but right here, this service valve, I don't know if y'all can see that really good, but there's a service valve right here, and this is the suction side. So the returning gas coming back is cold, and it goes in, and it goes in here to the, I don't know if it goes through the jacket or if it goes through over the windings. I think it goes over the windings. Cools the motor, cools the head and the cylinder. And because again, like I say, I've never rebuilt one of these, because it ain't that they don't, that you can't. It's just that it's more cost effective to just take one of these, send it off to the rebuilder and let them rebuild it. Because like this little compressor here, rebuilt is $2,500. If you buy a brand new one directly from Copeland, it's $3,000 or $3,500, around $3,500. So you can see, if you have the equipment to rebuild them, you know, to pull those stators and rewind them and all that kind of stuff, because that's a lot of times the problem, is the stator or the armature or rotor burns out, and so they need to be rewound or either a new one put in. And I mean, I'm sure you could probably order one, but if you ordered a rebuild kit for this, you know, that includes like the rotor and the stator and the piston and the connect, you'd spend more on the parts to build it than you would sending it off to a rebuilder and letting them do it. And so I'm going to see if I can get this bell off. Bad boy's on here. I'm going to have to get the old glad I had that bucket down there. I knew there was oil in there. Yeah, and see, that's different. That didn't damage it though. These things are heavy cast, man. I mean, this little compressor weighs about 150 pounds or thereabouts, because I mean, I had to pick it up and bring it in here with a rag. Well, goes to show you that I wasn't sure, but it looks to me like I mean, you can see I don't know if that's, I think that's the stator right there, and it's not like I was hoping, because there's them fittings, the bulkhead things right there. And let me get a light. Because what I did, it started leaking, and that don't smell burnt, but it started leaking about like in 2020, right when that COVID stuff started, and it's got a sight glass on the side around here, oil sight glass, so you can see how much oil is in the sump. And it was leaking around there, so I got a new sight glass for it, and I ordered a can of sealer. Now that sealer is mainly meant for like little pinholes, like in a coil or something like that. That, you know, because if fixing leaks in coils is a losing proposition, you're better off to just get a new coil, because you can fix one leak and 5 more will pop up. I mean, they just like that, because it's already, the copper tubing in the coil is real thin. It's not like the connecting piping, you know, like type K or type L, which is a heavy wall, or ACR, which is a heavy wall pipe. It's a real thin pipe because they want to maximize the heat transfer. So the when they start getting holes in them, little pinholes, you know, like I said, they're already thin, so that you can believe when they start getting pinholes, it's like paper thin. And so trying to, you know, most of the time, if you try to solder it or something, you just blow a hole in it, because you really can't get it hot enough to make it take solder unless you use soft solder or something, without just burning it up. I mean, you know, because with the silver solder, you got to get it pretty hot, you know. I mean, 1200, 1500 degrees, somewhere along in there, to melt that solder. And so you know, it's just kind of a losing proposition. So the only alternative that you have is to put a sealer in there, like you would in a radiator on a car or something, you know. And so I put the can, and it took me 6 weeks to get it because of that COVID stuff, you know, the supply chain interruptions and all that stuff, it was probably malarkey. It's probably sitting in a warehouse somewhere, and they just, you know, they're playing the game. But anyway, I finally got the sealer, and I put it in there, and it stopped leaking. And because it's right up in here is where it's coming through at right there. You can, if you let me get you a little closer up here. You can see this is the stator, and then there, I guess, would be your rotor right there. Yeah, there's the rotor. And I mean, it turns freely, so it's not like there's any scoring or anything like that on the cylinders. I mean, they're moving good. So the compressor itself is good, but right up here, there's them connections that are coming through that I showed you that was up there on the top. I mean, hopefully you can see that, and you can see the wires going to it. Well, it may be that the seals are on top. So I'm going to pull this box off, and I'm going to see if the seals are up there, and if there's some way that I can put them seals in there without having to pull this stator out. Because I mean, I don't know if it's pressed in there somehow. I can see holes in there, and that's probably holes to where they have some type of a puller that they put on there, and they pull that out. But it would seem to me that you would have an issue there, because to pulling it out, because that connector there, it seems to be, I mean, in the way of pulling it out. So I mean, I don't know. I mean, you know, there may be some kind of trick to it. I don't know. Maybe those things screw into this from the top. Maybe it screws down through into that thing there and screws into it, and that's how you get it, you know, would get it out. I don't know. I'm gonna find out though. I'm getting ready to pull this box off up here. This box right here, the electrical box, and move this camera up. Well, you can see it from there. But I'm gonna pull this box on off and see what I can see. And hopefully that's the way they do these. Like I said, you know, I work for a manufacturer of controlled environmental chambers. And so, you know, we didn't have time to be rebuilding them. We didn't have a rebuild shop for compressors. It was cheaper, more cost. Matter of fact, we bought compressors directly from the manufacturer. We bought that many. And so I'm gonna pull this out and see what we can see. sure what size that is. You know, and these bolts on the back, I would have thought these, because this is an American-made compressor, but Copeland's a high-tech company. You know, even though people wouldn't look at these and say high-tech, they make scroll compressors as well, and the scrolls are some of the most advanced compressors there is. They require incredible tight tolerances in their machining. I'm talking about hundreds of thousands tolerances. And because the actual scroll compressor, you know, from the research I've done on them, and because I've worked with them, the Arctic scrolls and stuff, they were, the idea for them and the design came out in like the 1920s or 30s. But they didn't have the machining capability to machine them to the tolerances that they needed to until the 1990s. Copeland was the first company in the world to produce a scroll, and they produced them inside of a vaulted manufacturing space. I mean, you had to have special access to actually go in there where they made these. Now these have been around for a long time, so there's a lot of people who make compressors like this. I mean, you know, Danfoss, Carlisle, and others that make this style of compressor. And so there's, you know, nothing unique about these, but the scrolls, yeah. And so so Copeland is a high-tech company. I mean, they design a lot of their own processes and all that stuff to build these things. But they done all these. This is all in metric, you know. Because when I went to take it out last night, I took all standard tools, and yeah, ended up there was metric. I had to use adjustable wrench and all that stuff, and that's what I'm gonna have to do here. I mean, I got metric sockets over there, but I'm not going to dig one out. It's just three stud nuts on here. You know, I mean, and they shouldn't. I mean, they may be a little tight, but I'm not opposed to using an adjustable wrench every now and again, but I don't really care that much for them because they don't tend to grip down tight enough on something and want to round stuff off. So there you have it. And man, they had a rat's nest of wiring in there too. They had 2 condenser fans going in there tied into the power, and power coming from there's a box like over here, like the compressor sets like this, and then there's a box here that's got a big capacitor in it. Actually, I think it's got 2 capacitors in it and a potential relay or a current relay, because what they do is this is single phase, but it's 230 single phase, and so it's got a start winding and a run winding, and the start uses a bigger capacitor, and so when they start it up, once the current drops down, then that relay switches over, and because you have initial inrush, I think this one here has a lock rotor load of 40 amps. And lock rotor means from being off. When it's sitting here off, it has what's called a lock rotor. And so whenever you apply power to it, you get an inrush, and it goes up to 40 amps on this. And then it begins to drop down, and that potential relay keeps it over on the start winding until the current drops down below a certain level. When it drops down below that certain level, then it swaps over to the run. And the run has its own capacitor, because I think what they're doing is they kind of making it like 3-phase, but it's single phase. Using that capacitor is energizing a third winding. You got your 2 windings for your 230, and then you have the additional winding in there to get it to start turning. I mean, that's how they do it. And because really motors like in a three-phase system, when you got three-phase motors, you don't need any capacitors or anything like that, because you got always got two opposing fields. And as where though in here you only have one opposing field at a time, and because of the nature of power, I mean it's just the way that it operates. And then see, you got a thermal overload here. There's a thermal overload to keep if the compressor starts running too hot, that right there will shut it off. Yep, I'm gonna have to get the sockets. I figured I would. Break out this set here because I've got a bunch of loose sockets over there. I need to get some rails to put them on, but right now I need me a bigger bench, but don't have it right now. Move some of this stuff off. Yeah, it's looking more like them seals are going to be right up here on the top, boy, and that would be nice if that's the case. They both, that feels a little bit tighter. Boy, that's loose, man. You know, that could be the problem. Yeah, that one's loose too. So what I'm gonna do is, could just be that that's all it was. It's just they needed tightening. See, I think I may have enough. I don't know if the nut driver will fit that or not. No, not big enough. Out. Get out of my way. Now you can see, and see that disc, that right there piece of plastic was on that thermal overload, and I guess that's from where the heat and that refrigerant and oil. If you look at it, I don't know if you can see. You see that oil on there? It was blasting out around these somewhere. And it don't really, I mean, when I look at it, I don't see no oil around them. But it was leaking there somewhere. And because, I mean, you got that oil there. And what I'll do is, I've got them nitrogen tanks over there. Whenever I get everything done, and that gasket looks all right. In fact, yeah, I mean that gas. I don't know if that's a gasket or if that's machined that way. I mean, some of this stuff is machined so precisely that they don't even need gaskets. But you can see, if you look, you can see there's some crud in there. And I don't know if that's maybe that sealer where it congeals or something. I don't know. And it says on the tag, it tells you what refrigerant that this compressor is designed for. And yeah, that's a gasket. It is a gasket. You can see. But it don't look like there's no cracks or anything in it. So, I mean, I may be able to get by with just reusing that. And as far as the torque, I mean, if I can't find, I may just go to Copeland's website and I can probably get that information as far as what the torque specification for this bell end here is. But they tell you on the legend plate, that blue plate I showed you, it tells you what oil was in here, and it says that this one uses polyol ester oil and R22. Well, it didn't have, I don't know what it had in it, because again, this compressor had been, the guy that I got the freezer off of told me that the year before he had another compressor put in it. And so and the guy didn't tag it or anything as to what refrigerant he was using. So what I did was, whenever it started leaking and lost its charge, I put hot shot, or one shot, which is a like a direct drop-in, what they call a direct drop-in replacement for a lot of the old so-called phased out refrigerants like R12 and 22 and 502 and all. You can still get those refrigerants because there's still equipment out there that's running it. And the reason is because R12 was the best refrigerant ever made. And the real reason I believe that they done this, and they've done it again here just recently, they went and reformulated all these refrigerants. Now they're using pentane and carbon dioxide and isobutane and all these others, I mean, carbon dioxide I can see, I mean, there's plenty of it. There's plenty of it in the atmosphere anyway. But, I don't know. I personally, R12 was the best refrigerant ever made. They just made up a story because at that time, because I looked at the statistics about the growth of the refrigeration, heating and air industry, and they were growing about 2% a year. Uh-oh. That ain't good. A piece of that phenolic broke off. Give me another rag now. This one's toast. Yeah. See that phenolic insulator, and those things are like forks. That ain't good, man. That thing just, because this bolt is tight. I don't know why it's so tight like that, but that thing slipped. Well, it seems to still be, but a piece of that phenolic insulator there, I don't know if y'all can see up in there, but if you see that yellow looking thing right there, you see where it broke off on this end right here. And just for me turning that, but I can see that there's a rubber seal there, and that bolt's going up through. And I don't know, man, that ain't. Let's see how one of these other ones come off. But anyway, the refrigerants, they make all these claims about, oh, the ozone layer and all that stuff, but really what I found out is that it was about industry growth. After that, when they passed the Montreal Protocol in 1994, or it might have been 1990 when they passed it and they implemented it in 1994. I can't remember. It's been a long time since I went through them classes and all that stuff, but I think that these things were just loose. I think that's all the problem was. Let me get a magnet to see if I can get that washer up out of there. So after they started phasing out all those refrigerants, come on, man, the industry was growing like 10 or 15% a year because everybody started replacing all their equipment. Especially like the pharmaceutical industry, and they always lead everything. Let me get another one of these. Double wrap. So they, it had to do with this one's overwhelming. Screwdriver to get up under there or something. If it gets catty-wonkered. There we go. Yeah, see, I'm not seeing a seal on this side here. The seal's on the bottom side. So all I'm going to do is I'm going to take and tighten it back down and see if I can get it tightened up good. And then I'm going to bring that nitrogen over here and I'm going to put a pressure test on it. And I'm going to test it at I'd say the maximum operating pressure on this thing is probably 250 psi. And they don't have it put on here. Usually they'll put on that plate, they'll tell you what the maximum discharge pressure is and the maximum suction. And the reason that is because those valves, those reed valves, they're just spring steel. They're just thin plates of spring steel. Probably, the discharge one's probably a couple of hundredths of an inch thick, and the suction one's probably 100. You know, I mean they're real thin, and so they have a pressure limit, because if you put more pressure than that on it, it'll warp the valves, and then then you got real trouble. And so I'm just gonna snug these things back down good, and it's almost like they need to be double nutted or something, even though they got those star washers on there. Yeah, they don't seem to. And man, I hope that when I go back to tightening this down, it don't break that phenolic anymore. It's almost like they got these cross-threaded or something, or boogered up the thread. That whole thing's turning. That's where the malfunction there is. And that's why them threads are boogered up, because what they did was they held them. That's why them threads are boogered up, because they had to hold this with something like a pair of vice grips and run that nut down until they got it down there, and then tighten it. Chinese made things, man, they ain't junk. Size that. It's like 8mm or something. Actually, that's 3/8. Just use some of the old channel locks. Again, I don't know. That broke too. See, that's where this thing got so hot. it makes all that plastic and that phenolic and stuff, it makes it brittle. Get my light and look in here. Yeah, see that seal over there on that side, nah, it don't look like it's sealing on that one side there. But I'm going to put that bell cover back on there, and I'm going to put a pressure test on it and see. Of course, I got to find something to try and plug up, put on these to plug these. Hopefully I've got some caps I can put on there and plug this end up, because that's in order for me to pressure test this. See, I think whenever you, these are sort of a three-way service valve. When you run them all the way in, this here, there's an access port on here where you hook your gauges up, a gauge port. That is open. Then when you back it all the way out, that's closed. But this pipe, where your pipe connects, and the compressor, when you back the stem, if you look on here, there's a stem. There's this valve stem that goes up in there, and it seals it off. And yeah, see, now this here is sealed off. There's nothing going to come through this pipe into the compressor with it all the way front seated. With it all the way back seated, when you run the stem out, back seated, this is closed. This service valve service port is closed off, but this here where the pipe is open. Now, I don't know if when it's front seated like this, it's been a long time since I've fooled with any of these. It's probably been, other than when I, put that sealer in there and had to recharge it. Then and by the way, there's that oil sight glass that I put in there. I got a special socket that it's like a spanner there, but it's a socket that goes in there, and it, you tighten that down with. I had to order a new sight glass and put it in there because it was leaking there, but it was leaking here too. And I'm just hoping that takes care of that. But I can't remember if, when you got this front seated, if the service port is open to the compressor. I guess I'll find out. But I may just go and see if I can't find me some plugs to put on these, some caps to go on them, because they're flare. This is 5/8 and this is 1/2 inch, and maybe I got some caps I can put on there and close that off just long enough for me to pressure test this. And so I'm going to turn the camera off for a minute while I gather to get the tank and the regulator and get it over here and a set of gauges and all that stuff and get it set up. And then I'll bring it back on and show you, how I'm doing it. Okay, folks, I'm back. I got stuff set up. You can see right here, I've got my nitrogen tank, and of course I've got it mounted onto my hand truck and strapped down because I'll show you. I mean, if you look, that thing's got 2,000 psi pressure on it. So you really you got to be really careful that you don't. Let me see if I can brighten that up some. Yep, I think it's as bright as it's going to get. All right, and what I found out, I hooked my gauges up and I opened it up a little bit and let a little bit of pressure in, and I could hear it coming in through the end here. So, but none coming out of here. So it was the way I thought. Again, it's been a long time since I really, done this every day. I used to do it every day. I've done it for every day for 12 years. Actually longer than that, for about 16 years. But I worked for that manufacturer for 12 years, Environmental Specialties, for 12 years, and so I've done this stuff day in and day out. I mean, and I've done a lot more complex stuff than this. I worked on cascade, ultra low temperature stuff, and so just it's sort of like the old saying about riding a bicycle. You kind of start doing it, and everything starts kind of coming back to you. And as far as torquing, these are, I'm not sure what the grade is on these. They look like grade 8. They're grade 8. And so I'm going to probably maybe torque these things to 80 pounds or something, just something arbitrary. And just to kind of seal it up good to where I can put a pressure test on it and make sure that these things, these bulkhead fittings, are actually going to be sealed. But I'm going to have to put operating pressure on them. I'm going to have to put about 250 psi on it to do a really legitimate test, because if you don't test it to what it's going to be operating at, it might not leak. And then when you go to running it, and the other side of that is they get hot. That makes a difference in stuff too. But generally when they get hot, you would think stuff would seal better, because the metal expands and all that stuff, and kind of has a tendency to seal stuff up. But this is just sort of shooting in the dark, hoping that maybe this will take care of it and I can put it back into service for a while longer, until we can either get us another compressor or another cooler. And I'm just, normally on these, I would use, these are what they call permeable hoses. These are the colored ones, blue and red and yellow. They're permeable hoses. They're designed to leak, and they will leak. But it's not like I'm going to be doing a month-long pressure test. I'm going to probably put it on there for about an hour or something, and see if it does any leaking around these fittings, these studs, because that's my big concern is that when they do with my wrench. And the other thing too I had to do is, I got this this thing here that's got all kinds of fittings and stuff in it, and I went through there and when I checked it to make sure that how this actually was operating for sure, I just quit looking for caps to go on here. But I did find this cap here, this stem cap, because the other one, when I went to take it off last night, it just crumbled apart. I guess it got too hot too, and it just broke apart. And so I just make sure that they're snug, because them stems, that packing gland on there, it'll leak too. Now I laid my wrench somewhere, and now I can't find it, and I didn't hang it back up. Oh, there it is, hiding under the bottom here. Just give these another check. I mean, I want them tight, but I don't want to go stupid on them and, you know, mess it up, distort it down there in the bottom, and make the leak worse. So let me get my torque wrench and see if we can. Well, now, that's good. Already set at 80 pounds. And I'm using a dial type torque wrench. Let me get my socket off this impact. Back. I may go ahead and just do a little impact to them. And of course, like anything like this, you want to do a cross, you know, a pattern across. Alright, now I think they tight enough on that. Now I can torque them. And I mean, the torque specification may be a lot higher than that. I mean, it may be, you know, 150 foot-pounds as far as I know, using grade 8 bolts. But I figured for testing it, pressure testing it, and then I can go to, like I say, I can go to Copeland's website and find out what the actual torque specification is for it, and then torque it to that. Well, are you not going to click on me? Don't tell me I got a defective torque wrench now. Because I know that's more than any 80 pounds. Well, I'm just going to snug them down for right now. I had something I could check this with. One of those torque testers. Because I can tell you right now, I do not want to go breaking off any bolts. Let's see, I think I got another torque wrench over here. I know I do. Let me grab it. Actually, I got a couple of them over there. Set at 150. It's like connecting the rod. Let's set it at 100. And by the way, on this end plate, it's got an arrow pointing up on it so that you know what direction to put it back on there, because it'll go on there many different ways. I tell you, man, run these things down a little bit more with this impactor. Oh no! Exactly what I feared. Broke the bolt off. Well, I'll have to get that out of there, but right now I think I got it tight enough I don't know what's up with these torque wrenches. They're not clicking. Could be that oh well. I'll have to set me up something and get a known good torque wrench and test them. But it should be tight enough, more than tight enough to hold a leak test. Yep, coming out of that hole. Crap. Well, you know what I gotta do? I gotta take that off and get that bolt out. Well, I know the next time I won't use this. Just do it by hand. Well, thankfully, the stud is sticking out of there, man. I'm gonna shut this off and get that out. Well, fortunately, that I was able to get a hold of it with that pair of channel locks, and it was I mean, it wasn't tight at all. I just hope that, you know, it might have just been a defective bolt, but I'm gonna go and see if I can locate. And I can see right now they got Loctite on there, so I'm gonna put Loctite on it too. But it was leaking out of there, and man, I'm gonna have to figure out something that I can put up in there where that phenolic broke off on that side, because I could see a gap in there a while ago in that seal. Otherwise, you know, I don't know just how easy it would be to get them out. I mean, that's I know one thing too. I'm gonna get my kneeling pad because my old knees can't take that asphalt for too long. Yeah, see, I can see over there. I can see where that phenolic broke, because that phenolic was putting equal pressure across that seal. Now it's not able to get equals, you know. So what I'm gonna have to do is get some kind of a piece of plastic insulator that I can stick up under there and then clamp down on that and see if that'll give it the equal pressure that it needs. Maybe. I mean, that's the thing about that kind of stuff, that, you know, phenolic, they use a lot of that kind of phenolic stuff. It's like a wafer, layered wafer. I guess it's phenolic. It could be something else, but it gets brittle. I mean, when it gets hot after a long time, I mean, it'll start getting real brittle. And that's what happened there. When I tightened down on it, I mean, it just clapped. And I didn't really tighten down on that hard. I mean, because I knew that stuff's kind of fragile. And but you would think you'd be able to snug down on it enough to seal that O-ring, that seal there. All right, well, I'm gonna put the camera on pause again and go see if I can find me another grade 8 bolt. I've got a ton of bolts, so I'm sure I've got one somewhere. I just hope, I mean, these are, you know, these threads may be metric, and if it is, man, I mean, anyhow, I'm gonna put it on hold here. All right, folks. So I figured this out, what they're doing here. I'm gonna bring this up a little bit. Hopefully y'all can kind of get the idea. Right here, this is one of those caps that surrounds, goes over this here, and you notice that it is got a little shoulder there that goes down in there. Well, this, I don't know if that's part of the casting. That looks like that black epoxy. Now, I don't know if it is or not. It may be part of the casting, and that's just a coating or whatever, you know, paint coating. But this slides down in there, and that phenolic thing, oops, there's a piece of it, that piece that broke. That is strange. It's got 3 little tubes that are part of it. 3 little tubes that slide up into these holes. And they put an O-ring, a rubber, it ain't really an O-ring, it's a rubber gasket seal or whatever around that plastic tube, and they slide them all up in there. And so I don't understand. I mean, I guess this is supposed to help seal it, but where it's coming out at is around this. So my solution is, I'm gonna try it. I mean, I can just try it, is to epoxy that and then slide this back down in there and see if that epoxy will seal it up. I mean, that's the only, you know, I thought about silicone or something, but I don't think silicone will hold up under the temperatures. So, and this, I'm gonna have to take a dye to it and run around it to clean them threads up so that I can get that screw off of there to do that. But I'm gonna just mix up a little bit of epoxy, shove it down in there, and then shove this back in there so it'll squeeze up into anywhere it can and out and around it, because these things, they're turning. This one ain't. This one's still sealed in there. And that could be what this black stuff is. They put that around it to seal it. But, you know, I got to do something that's going to seal this stuff up. And I'm going to look at that JB Weld and see if it's dielectric. If it's not, I'll have to find something that's dielectric that won't short it out. And so I'm going to end it here. I'll be right back. And I'm going to just ponder on it, and I'm going to go get that epoxy I got, and I'm going to look at it and see what it says about its dielectric capabilities. I may, if I don't do that, then I may try putting these back in there and then getting the rubber seal and putting up under that washer and then tightening it down and see if that seal, get a seal that'll fit snug on here, and then see if maybe that'll do it. I don't know, because and that's probably, this piece here, it was probably already cracked or something, and it was broke away from that tube, and that's how it was, you know, what caused it to start leaking. You know, because this here was up against that rubber seal. It was, you know, tightened up, snugged up to that rubber seal, and that was probably how they were sealing it up. You know, that was probably, you know, the pressure from inside the compressor pushed against that phenolic plate with them tubes and pushed it up against those rubber seals, and that sealed it. And now there's nothing really pushing up against it. So, you know, I gotta try, you know, short of, and I just don't see how without pulling it, and I don't know how they got that stator out of there with these things there, because they're blocking it. They, you know, I can see, when I look in there, I can see the stator, the outer portion of it. Now that might be part of the casting, I don't know, but it's got a gap around it, and you know, and that stator is wound into it. So there's got to be some way to get this thing out of here without, and it looks to me like it's forked. It's got like 3 forks, and it just slides in there and then over them bolts. And I'm pretty sure, I bet you that's exactly what it is. I may can order that. Meow. My cat. She's wanting attention. What happens when I... Nope. No, it's got holes through it. So I don't know how in the world that they're able to get that on there with this stator in there. And I don't know how they're able to get the stator out with it in there. And it's a mystery. I wish I had them manuals, because the manuals show you a lot of this stuff. Because I mean, they actually show you how to rebuild them in the manuals. But so that's what I'm gonna do. I'm gonna take that dye and run it over them threads and see if I can clean them up. And then I'm gonna just see if I can put something up under them, up here on the top, to see if maybe that'll seal it up. I don't know. I mean, that's my last resort. And I was just basically striking at the wind when I decided to do this, because I knew from what I'd heard in the past that they're not, it's not like just taking a lawnmower apart. I mean, there's a lot more to it, and because of the pressure, they just don't seal. And well, I'll have to figure something out. I'm gonna try that and see. I mean, if it works, it works. If it don't, it don't. But there you have it. And once I kind of figure out something, then I'll do another little video and thing here. Do another little video and update you on the if the solution works. If not, then I'm gonna have to just start looking for another compressor. I've got one down there in my storage trailer, but I'm not sure what size it is or anything. I'll have to go down there and look at it. It may be the same thing. It's a I think it's a K body, but it could be a high temp or something like that. This is more of a medium temp, and but there you have it. I hope maybe this gives you an idea of the foils of doing this kind of stuff, what you run into, and maybe I can figure out a solution. Maybe not, I don't know. I'm gonna try and see if maybe something I can do to seal this thing up, at least to get me through until I can afford to get a compressor or whatever. So with that, I'm gonna end it here, and have a good one.